Okay, so we start the class, continue on that, wait on the electronic, okay? Okay, so can you see on the screen?
Yes.
Yes.
Very.
Yes, sir.
Okay, let me share again.
Desktop.
It okay now?
Blue
We
screen
see.
desktop. Sine waves.
Okay, we see it.
Okay, let's see. This thing we already done last week, but basically you have to go through it, okay? And make sure. See, man. So now you see a small one, right?
Correct. Okay.
Okay, we already done. Okay, if you get a question, please stop me. Okay. Okay, last time we're talking about diode. Okay, and we understand a diode, they get the ideal diode, 3-volt diode, and a 4-volt bias. Reverse bias, that means the diode off. 4 volts means the diode on. What happened for the ideal diode? If they talking about the ideal diode, how much do you know? This is a very important thing here. Ideal diode, then VD will be 0 volt. If they on, okay? Forward bias, that means VD equal 0.7 volt or 0.3 volt, depending on silicon diode or germanium diode. Okay, so that is they talking about second approximation. That's normal. Every time you say they on, they can be using the battery 0.7 volt. The thing is, when they on, they don't have any more diode in the circuitry. They must be substituted by 0.7 volt. Okay, so now for this circuitry here, we want to calculate the voltage and the current. First question is a diode on or off, and you get a positive 10 volt here. So this side higher than the other side. The other side here 0. So the voltage on the anode will be higher than 0.7 volt. So the diode will be on. So the answer will be diode on. If they calculate the V out, When the diode on here, you substitute diode by the battery, 0.7 volt. And when you measure across the battery, you get that voltage, so 0.7 volt. And they want to get the current I flowing here. You get 10 volt here, 0.7 volt here. You take 10 minus 0.7, divide to 1K. That's what you get, 9.3 milliamp. And what the voltage across resistor, okay? That means from here to here, you get 9.3. Any question about this thing? Okay? And the second one, they question same thing. The diode on or off, you get 0 volt here. On this side will be 5 volt. So diode will be off. They open. Okay? And if they asking a Vout here, when they open, no current flow. No voltage drop across the resistor. So whatever voltage here and here will be the same. So that's why Vout equals 5 volt. And if they want to calculate the current, open circuitry, current will be 0. And V across resistor here equal I times R. I equals 0. So that's why V equals 0. Any question? Okay, for this circuitry here, VD 0.7, diode on or off. So you can see easy 5 volt on this side, 8 volt on the cathode. So you cannot get the voltage greater than 0.7. So the diode will be off. Okay, and the current equals 0 anyway. No current flow. They off, they will be open. Okay, number 4. The question is just they be on or off. On means forward.
Can you scroll little bit up, sir? Can you scroll little bit up for number 4?
Number 4.
Scroll little bit up.
If you can scroll the screen up a little bit because the bottom is chopped off.
I cannot.
Oh, okay.
That's fine.
Okay. Man, just a minute.
It should just be a straight line anyway, so you just,
Okay, just a minute.
was that quiz 3?
Yeah, just a minute.
I see you have a quiz folder. Would it be under that?
Okay, so we get that through. The diode will be forward. The thing on this side negative. This side 0 volt, so they will be on. Okay, so this is just try to let you reading. Okay, basically that will be coming out from the left volt. When you're doing the left volt, they will be asking you, they will be displayed like this one. So diode normally permit electron current flow in one direction. Okay, these are more physical. We don't care much. You can see that contain negative electron, positive the hole, and this they call a depletion region. Okay, and the junction between positive and negative. Okay, and this is a symbol for the diode. On this side anode, this side cathode. When n-type semiconductor metal is drawn to p-type material, a depletion region. This is a depletion region. Okay, it forms. Diode normally permit A. Alternating current flow, B. Current flow in one direction, A or B.
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 All right. The extra voltage potential required at the depletion region for diode semiconductor junction, they call a barrier voltage. Okay, that's a barrier voltage. Like, you know, silicon 0.7 volt, germanium will be 0.3 volt. The barrier voltage for germanium diode 0.3 and silicon 0.5 up to 0.7. The barrier voltage is also called the diode forward voltage. What that means? That means the barrier voltage 0.7 volt. That means at least 0.5 up to 0.7 volt allow electron to move it. So that's why you get a current in a silicon. However, for the germanium they need only 0.3 volt. Will allow electron to move it. The barrier voltage for silicon diode is about ABC.
B. 0.6 volts.
B, correct. When a negative voltage is applied to the cathode of the diode, electrons in n-type material are forced to closer to the junction. Similar positive charge in the p-type, okay, of the anode are attracted toward the junction by increased negative charge across the barrier. Okay, so basically in here they just try to telling you this is the barrier depletion here. If they narrow, okay, that means later they can allow electron to move. Electron moving, then you get a current. When they get a wider, no electron moving. So that's why they will be off. Okay, so they plan for forward bias. Now, a diode is fully forward biased when LB.
A.
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 Okay, this is also try to explain to you. Same thing. you can read it. Okay, that reverse bias. That means the depletion will be wider, no current flowing. A diode is reverse biased when A or B.
A.
Very good. A. You can get a right away answer. You're doing okay. Okay, now they explain to you.
Mr. Fan, what was the last answer again? Was it A or B?
It was A.
A?
Yeah.
Was bias?
Yeah.
Okay, thank you.
Okay.
Welcome.
Now this is a sideway here. Apply to the diode. And the output of the diode will be when the positive come in, diode will be on. So that's why the output, you can get this signal, copy from here. However, when you get the negative part of the sideway, then the diode will be off. So that's why nothing. Okay? And they keep going. So that one signal coming out here, they will be halfway rectified. Now, half rectified or rectification, what that means? How many people understand when they're talking about rectification?
That's changing an AC sine wave into a DC ripple.
It's a filter.
Basically, rectification means converting AC to DC. Okay? And this output here, they call a halfway rectified. Why half? The thing is, this is a full cycle, but you get only one half of that. So that's why they call halfway. Okay, and also they go to more detail here, resulting output voltage or current. That's what they call a pulsating DC. Okay, and current, and they call a ripple. Okay, which flow in one direction or not at all. That means this is they call a DC. Okay, the thing is when the point is the current going left to the right. Zero here, no current. And right here, the same direction, left to the right. Okay, so that's why they will be DC. However, that one they call a pulsating DC, not completely DC only. Okay, and that's why they call a halfway rectification. Okay, when the diode function at a halfway rectified, its output is a DC pulsating voltage when the AC input A or B.
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 A. So far, you guys doing very good. Really understand. Now, that's what they're talking about. Characteristic curve for the diode. Okay, I just quickly explain to you, not go too much detail. You see, that is ID current diode. Okay, that is the voltage diode. So when the voltage VD go up to 0.6, 0.7, okay, and they no more increase. However, the current will be keep increment. You see that voltage will not increase, but the current will be increased. Okay, so what is the device for the diode? They can be, let's see, linear or non-linear. So diode will be linear or non-linear.
It's a non-linear.
Non,
Yeah.
Non-linear on that
It's
area.
non-linear. Initially up to 0.6 and then
now you have to understand that thing. What is linear? Linear
as
means,
current
okay, I
as
tell
voltage
you.
increase, current increases. That is linear.
Linear means voltage increase and the current increase, both going up or both going down.
Yeah, but
Together.
go in a kind of proportional way. That's mean linearity. You increase voltage, you get a proportional amount of current.
No. I'm talking about the definition for linear.
Okay, go ahead.
Linear means what? Voltage increase, current increase. Voltage decrease, current decrease. Both go up or both going down. That's linear. None. That means one going up, the other not go. That's a none. So I already telling you here, diode current can go. However, voltage go up to 0.6, 0.7, and no more increase. So that's why we say diode will be non-linear. Telling me which one will be linear?
Resistor?
Exactly. Resistor. Resistor, if voltage increase, that means current increase. Voltage decrease, current decrease. Okay? That also again, only thing that they're telling you, they park here for forward bias. They park here for reverse bias. Okay? That means the diode on in here, diode off on this area. If you keep apply more negative voltage, then they will break down here. Will be cooked the diode. Okay, too much thing here, we don't care. Okay, the path of a diode DC characteristic curve. That describe forward bias operation. Right hand, left
B.
Right side.
right side. That means here. Okay, that's a reverse. Okay, and now reverse you already know, right? Left part of the diode, that means here. They will be
B, the reverse bias.
B, exactly, B. Okay, talking about that voltage here. Okay, above the barrier voltage, the diode voltage drop A or B.
It's nearly constant.
Correct. I mean, after that one right here, the voltage will be constant. Okay, when a diode is reverse biased, the variable small current net flow equal
Leakage.
Leakage,
leakage
leakage current.
now B, leakage current. Okay, that's what they explained to you. Already telling you. Now, this is how to test the diode. You connect the red into anode and the black into cathode. Okay? And if they get, let's see, 2 reverse, that means you connect red into this side, okay, and negative into the other side. So if you connect the forward, you can get 0.5 volt or 0.65. And when you connect this way, I think they will be get nothing overflow. So the diode will be working. Let's see, do you give any answer here? The
Are
figure,
are we using a ohm meter or a voltmeter? Is this a voltmeter or ohm meter?
we're using a DMM.
Okay,
It's
so
a
you are
voltmeter.
measuring the voltage, not resistance. Am I right? Of
No,
the diode.
no. Now, if you're using the DMM, they can measure voltage, they can measure the resistance, and also they can measure diode, right?
Okay, yeah.
Now, if you set into the measure diode,
Mhm.
that means you can get forward, you can get 0.6 volt. The
Okay, I got it.
diode will be good.
I got it. Thank you.
Okay, and now on that one, the figure shows the ohmmeter connect to that diode. The ohmmeter indicates overload. The diode is
Bad.
A.
A.
bad.
Hey,
Okay, they will be bad. If they display 0.6 volt, they will be good.
I'm sorry, Mr. Pham. I have a question about the measurement. Should we turn off the power supply in this case before we apply the measurement, or we keep?
No. Okay, now, right now, I'm talking about single diode. That means diode not in the circuit. Okay,
Okay.
now, if you want to measure the diode inside the circuitry, power completely must be removed.
Power on. Okay.
Okay,
Thank you.
I
Thank you.
will be, I will be telling you how the meter can measure the resistance. Okay, the way
Okay.
they do it, but not now.
Mr.
Okay.
Pham,
Thank you.
question. Mr. Pham, question.
Question?
Yes, question regarding power removed from the circuit. Does that also mean verifying that the capacitors are discharged?
That would be a good idea.
No, not. I don't think that's a problem. Normally, you want to test the pack on the circuit board. You better take it out. And when you remove the board out of the system test, I don't normally we deal with the electronic. Then capacitor cannot be need to be discharged. Okay. Only thing is you're working on the TV or on the very big circuitry, then you have to discharge it. No more voltage. Okay, any more questions?
Thank you.
Okay, now we're talking about half-wave rectify. This is a circuitry half-wave rectify. And right now they deal with ideal diode VD equals 0. So if they on, they just like the wire. Okay? Now, if you apply input the sine wave here, so when you get a positive input, you turn on the diode. So the output will be copy of what you get here, right here. Okay. When you get to the negative part here, diode will be off, so you get a 0. Okay, and they keep going. They rectify only positive, not negative. So that's why they call halfway. And the period from input from here to here, and the period output the same from here to here. So they're telling you the input frequency and output frequency will be the same. Okay. Now, for second approximation, VL equal VP minus 0.7 volt. Can you understand why VL equal VP minus 0.7?
Yeah,
I think it. Okay, go
0.7
ahead.
volts, the voltage drop across the diode.
Okay, now, when you turn on the diode, we're not talking about ideal anymore. We're talking about 0.7 volt. So when you turn the diode, what I'm saying, you have to substitute diode by the battery, right? You don't have any more diode here. Okay, so can you wait for me? I will be changed from my desktop to my iPad. Okay, so I can explain to you later on will be more detail. Okay, just a few minutes. I stop that one. Okay, so you see now, right?
Yes, number 1 and number 2.
Yeah, that's what I changed it to my iPad.
Mr. Fan, could you repeat the last that you said when you start the circuit that the symbol diode should be replaced by a battery symbol?
That's what I try to explain to you.
Okay, thank you.
Okay, so this one here. Now let's see which one. This Okay, let's see. I redraw that one. Okay, when you get sideways coming in. Now, the diode you say they on. No more diode. You substitute diode by the battery. Positive here, negative here, 0.7 volt. You see that? The thing that you said the diode is on. Okay? So now, when you draw, that 0 volt. First thing is you say the diode on. At the output here, V out. You get 2 voltage, DC and AC. What DC voltage equal?
0.7.
This
What the DC voltage
Half.
equal?
Half of the AC based on the graph.
Man, when you're looking at the output here, okay, and you get a sine wave right here,
Mhm.
get a sine wave. And also I said, you set the diode on. You have to remove diode, put in the 0.7 volt DC. My question is at the V out, at the output here,
should it should be
get
the
voltage.
should be in minus the 0.7.
No, I'm talking about display. At the output display, you get
Okay,
voltage.
the half of the sinusoids that you are applying.
You get a sine wave, right?
Yeah,
It should be a negative,
or the half.
negative sine wave, right?
Get the AC. What the DC?
DC is 0 here.
Come on.
0.7.
VP, it's VP minus 0.7.
You have to get
0.7 volts
minus,
riding on AC.
minus 0.7.
0.7.
That's what you get, minus 0.7 right here.
Hmm.
You see that? And now, also you can get the sideways. And the sideways, that will be a 0 right here. Okay? And that will be minus 0.7. Okay? So now, this is minus 0.7. So you get a sideways, this the part right here. They will be going this one here. Okay? And this will be a 0 here, and you get another one. Now, if I want to calculate a V peak, if you're looking from here, ideal, V peak going from 0 to the top. Okay? However, when you get a 0.7 volt, so V peak will be going from here to here. So that's why they say take the V peak minus 0.7. Okay? So if you get, let's say, 5 volt, Okay, 5 volt peak to peak. That means in here you get 2.5 volt peak. However, in this case, what you get?
2.5 minus
0.7.
0.7.
Minus 0.7.
That is 1.8.
Yeah, I don't care what equal. Okay. However, you understand if the peak have to be measured from 0 to the top. Okay. So basically, they already going down right here, 0.7. Okay, that's a key thing you have to know.
Hmm.
Okay, now, next part we need to know before we keep continuing. Transformer. What is a transformer?
To transfer something, here in this case, voltage or current, power.
Yeah.
Step up or step down.
It's an inductor. It's an inductor. It couples AC power. It's an inductor.
What is the definition? Basic for transformer. Okay, basically, transformer transform one voltage to the other. Okay, like you see the three wire on the street, 400 voltage. However, they go into your home, they get only 120. The thing that they need the transformer. They transform from one voltage to the other, not AC to DC. To transform from AC to DC, what you need?
Rectifier.
Diode. A
Diode.
diode.
Very good.
Diode.
Diode. That's very good.
Mhm.
And now, primary uh, on the left side, VP. That means primary. Okay. On the right side, VF, they call it secondary.
Secondary.
NP, that means the winding. How many wide? How many turn they make for the transformer primary? And that for a secondary. Only thing is what you need is if you get the primary voltage and you want to calculate the secondary voltage, that is the formula. V secondary equal NS times V primary divide to N secondary winding. If NS greater than NP, step up transformer, or NS less than NP, step down. Okay? That means if you apply 120 volt and the V secondary 240 volt, that means step up. Okay? And if you apply 120 volt at the primary and you get 24 volt at the secondary, that means they step down. Now, the next one, full way rectified. Okay? Very easy. I'm not talking about the circuit yet, but I'm talking about input output here. You can say positive output will be positive. Negative output also positive. That means a complete one cycle. Okay? From here to here, one cycle. They will be rectified both. Okay? Both positive and negative. So that's why they call full way rectify. Okay? If they rectify only one, that means halfway. Now, from this circuitry, they using two diodes and also the transformer. The difference between the part, I showed you the transformer. In this transformer, they draw right here.
Center tap.
That's what they call a center tap. Transformer. That means they divide output secondary into two half voltage. Okay? They take the whole thing, divide by two. You get the first one here and the second one on the second. Okay, that is they call a center tap transformer. So when the output coming out, they amplify both. Okay, will be explained to you more detail on next page. Only thing is, if you say you get a pointer here, diode, which one on? This one will be on, right? This one will be off. So that's why the positive coming out. Okay? When they get a negative, you see the sideway here. When the positive here, and also on the other side, you get the same thing. Okay? They opposite. So when they get a negative here, this will be off. However, this guy positive. So this one will be on. So that's why you can get positive coming. Okay? And this what they call a full way rectified. And now
That's more efficient.
frequency output will be double, equal to times frequency input. So if you get a 1 kilohertz, 1K in, output will be
Okay.
double. That's what they're using for ideal diode. Okay? If they not, then they have to be going down 0.7 volt.
Mr.
Now,
Pham,
yeah,
the first one, the DC voltage, VDC is 2 times VP, and then slash 6.284. What is that slash 6.284?
yeah, that's a good formula for calculate the DC average. We not pay attention on that. If you want,
Okay.
you can just using the formula.
Okay, go ahead.
Now, another full way rectify. You see the output are same. Okay? That means they rectify both positive and negative. However, this a different way. They using the normal transformer. You see that? Just a normal. Not a center tap. However, they need the force diode connect this way. We will explain to you how they work. However, they can do the same job, but this bridge rectify much cheaper than using center tap transformer. The thing is, normally transformer cost very cheap compared to the center tap. And also diode maybe 25 cents each. So that's why if you're looking into any power supply, they will be using rectify, and they using that with rectify. They're not using center tap. The thing is got too high. Uh-oh. Okay, so just wait for me. This is a version.
Hey, Mr. Pham, can you explain how those 4 diodes work one more time?
Yeah, that's what I try to say. Okay, I have to stop share this one. So I not get the right one. Okay, now I can share back to my desktop. So that's why I say I telling you guys have to upload the new one today. The last one we need to adding more. Okay, that one halfway rectified. Okay, on the new one now you can see I try to give it to you more detail. This is ID equals 0. Okay, so if the input is 4 volt, then the output will be 4 volt. The display different, the thing is different volt per division. They set it up. That's for ideal diode. You don't have a VD equal 0.7. On that one here, a little more detail. I set the diode on. You can get minus 0.7 right here. Okay, and volt peak to peak will be less than on the ideal. So if you're looking on the display here, okay, so basically the peak will be going from negative 0.7 up to here. So you want to measure the V peak, they must be start from 0. So that's why you have to check 4 volt minus 0.7. You get 3.3. Transformer, we already go. Okay, now for the circuit cell, they want to know V secondary and the rectified peak voltage VIL current through the load, and they gave VD equal 0.7. Okay, now can you do it for me? Go ahead and do calculation. Tell me what you get.
153 milliamp.
You get a VP 170 someone, okay? I will try to see.
No, it's a step down. It's a step down transformer. You started out with 156 volts.
I
It's
don't
a
care power up, I get the value. Just tell me what answer you get.
Okay.
I just want to know how to calculate it. Okay, 78 volt. If you don't, you not get it, or you don't know how come they come up with that number, let me know. Try to explain to you. That means you take 156 times 1, divide 2.
78.
Yeah, 78 volt. And now they want rectify peak voltage. Just tell me what the value.
You got 78 volts divided by 1 kilo ohm. Get the current. It would be 78 milliamp. Then 78 milliamp.
What number, Joe?
77.3 volt.
70.7.
No.
Yeah.
It's 78 minus 0.7.
What you get?
Yes, 77.3. Yeah, 77.3 volt.
Exactly what we just telling you.
All right. That's pretty
Okay,
good.
do not quite follow it. Stop me, okay? Let me explain to you. You be a technician, okay? Not assembler.
Well, Mr. Pham, I have a question about number 1, the V primary, which is should be, so it's 2 to 1. When we divide it by half, I was confused. Maybe I thought like the 78 is
Okay,
the secondary voltage.
look at back the formula on the transformer slide. You just apply the formula.
Okay.
You time NS divide NP.
78 volts.
Yeah, 78.
And Mr. Pham, the proper way to say it is step down, correct?
Yes, for sure.
Okay.
Coming in 156, coming out only 78. Step down transformer.
Steps down
Right.
2 to 1.
Ratio is 2 to 1.
Yeah, depend on the ratio.
The ratio given is 2 to 1.
And also, I make sure for either take 1 or take 2. This semester based on your assignment uploaded. Okay? If you not upload it, you stay here forever. Even
Hey,
you take 1 or take 2, I don't care.
So Mr. Pham, so the current is 77.3 divided by the 1K, is that correct?
I don't know. Just tell me the answer.
No.
Yes,
You talking current. That's the voltage. We're dealing with voltage.
77.3 milliamp.
Exactly.
There you go.
77.3 milliamp.
Divide the voltage by 1K.
Just The thing is, you see, the way I'm teaching now is quite different in the past. I have to make sure I guarantee you're able to do it.
Divide the load, I load, the current of the load.
That means you take the output divide to 1K. Rectify voltage output 70.7.3 divide 1K. Okay, that's what the full way rectifier will already explain to you. Okay, now I tried that given you a little more explanation for the full way rectifier using the center tap transformer. Okay, now you get a sideways primary here. When they go to the output, they divide by 2. The secondary, half of secondary, and a half of secondary. Okay? And if the positive here, then you get the negative here. And the negative here, positive here. Okay? So the first positive, you turn on D1. Okay? That means you get this part of positive coming out. When you get the part negative here, then they will be positive on this side all the time. They have to be opposite. If negative here, then you get positive. And this positive turn on this diode. And this positive coming out again. So that's why you get full way. Okay? This picture will be given to you more clear what's going on at the secondary for the center tap transformer. Any question on this?
Would that be referred to as a split phase?
I didn't hear you.
Would you call that a split phase transformer since it's center tap?
Yeah, they just opposite,
Yeah.
not the phase, the leading or lagging.
Can you draw the output signal?
Output signal, you want it, I going back here. That will be look like.
Okay.
That's a full way.
Okay.
Okay? That picture just shows you what's going on. A half of the secondary. The thing I did is, to me, in the past, I mean, I'm engineering. I confuse. I don't understand. So now it makes more clear. When you get divide by 2, if input here positive, the other side must be negative. That's what the center tap transformer. Okay, so in here, they just try to give another one with 1 and 2, and you get the voltage here. Output, they will be minus 0.7. We already done.
We also have an increase in frequency, right? Double the frequency on the output.
Output will be double frequency. Input 1K kilohertz, output 2K. Okay, so basically that's what they try to give to you. I'm going back that one. Given to you a little more detail here. Okay, this is a plus and this is a negative secondary. And at this point, you can get 3 second divided to minus 0.7. Okay, and this voltage will be the same voltage. They both divide 0.7. And now, this is finally, you get the input here and the output halfway. And if you're looking for the time period, input from here to here, and the output will be from here to here. Okay, just a half of the period of the input, so the frequency will be double. The thing I go to the textbook, I try to looking on everything and whatever need to help your guy understand. So that's why I can show in here. So you get 100 minus 100, 2.1. So that's why you can get output here will be 100. Okay, 200 volt primary go to the ratio 2 to 1 divide by 2. So that's why you get from here to here secondary 100. However, the first half you can get only 25 volt. Okay, and the other one will be 25 volt. Now, this is the bridge rectified. Okay, we already get through it. Okay, now this is a little more detail. It's here. Okay, so first thing, I want to stop this handout at this point, continuing tomorrow. And now I want to go to the quiz number 3 for maybe 30 minutes. We'll be done. Okay?
Mr. Pham,
Yeah.
quick question. On the list for electronics lectures, I'm not sure, but the binary arithmetic and Boolean and logic gate, the last two links, they're not working. Are they correct for not working, or they're supposed to be? I just wanted to, on the same area where the PDF file is for this class.
Now, the thing is, you're talking about binary.
Yeah.
That's the textual, not tech one.
Okay.
Okay? Tech
Right.
one completely different on textual.
Okay.
Tech one you learn electronic. Textual you learn how to deal with computer binary.
Okay. Thank you.
Yeah. Now, make sure whoever not download the quiz. Okay. Number 3, do it. The thing I don't want to give a too much detail on lecture and you not understand. Okay, that will be that one here. let's see. We're supposed to share. How come? Okay, you see that?
Yes.
Yes.
Okay. Now, for this circuit here, they want, basically they want to calculate the current go to the 1K ohm. And also they calculate the voltage across this thing. So if you're looking on the circuitry, first thing you have to tell me the diode will be on or off. If you're looking on this circuitry, the diode will be on or off.
Should be on.
Yeah. The thing is you get 36 volts here, and the other side will be round. They must be greater than 0.7. So the diode will be on. Okay. So now, when they on, they will be substituted by 0.7 volt. How can we do? Who can do it? Just tell me, how can you do?
Hey, Mr. Pham, can you go back up a minute?
Yeah, just a minute. I don't want that anymore. Cut. Okay. Now, I want to copy this circuit. Copy. Paste to that part here. Okay? So,
I just wanted to ask a question, because you went over superposition and Thevenin's. Mr. Pham, if you get a diode like that and it's forward bias, you said once you determine forward bias, then just put in a battery, correct?
put in the battery right here.
Right. Okay. I'm just asking a question. Okay. So you would put in a battery right there. So now once you put that battery in, you would work that circuit from a mathematics standpoint, like you're doing superposition.
Whatever you want to do.
Because in superposition, let me finish. In superposition, you said work one battery at a time. So you would short one out and then do the circuit, then put the battery back and short the other one out and do the circuit. Correct?
In superposition, that's correct.
All right, thank you, thank you.
However, the way they using will be happening. Okay? Some people are asking me how come we using voltage divider to get the voltage here. That means some people try to take 36 times 3 divide 3 plus 6 to get a voltage right here.
Mhm.
But we cannot. Why? Cannot using the voltage divider.
Because different nodes?
No. Someone using voltage divider, they say 636 times 3 divide 6 plus 3 to get the voltage here. But we cannot. I want to know, how come we cannot do it?
The circuit after that is open. After that is open.
Only thing is if you're using the phone, you're using the superposition, then you can, like battery, you can short it one, get another one. However, my question now is, a lot of people asking, you can using voltage divider. Take that one time, 3K divide 3 plus 6. But I said, no, you cannot. Can you tell me why we cannot do that way?
This time is a R1 is a series with R2. That's right.
There's only 0.5 voltage
Yeah,
forward.
you understand a voltage divider law only apply for series circuit, right?
Right.
Series circuitry, you get the law, they call a voltage divider. However, if you're looking into this circuitry, and you can see this thing here, the current flow from here, when they go to this point, one go here, one go here. So they not a series, okay? You cannot using voltage divider. If you get only one source here, and you get resistor here to ground. Now voltage divider, okay. Okay, the thing is the current will be same current. But a different current then cannot be voltage divider.
So on our original problem here, where you got the parallel circuit at, right there where you just put it in the square, that you do the superposition to make that work.
Yeah, but the thing is normally, if you want to doing solving for that one, they're using Thevenin. Okay, Thevenin volt theorem. What they want to get only one source, right? And one resistor. Then that will be connected to the load. So V here, Thevenin, and R here, Thevenin. Okay? So
So 3 in parallel with 1, and you then.
not yet.
Oh, okay.
Now we want to calculate V Thevenin. Okay. If you want V Thevenin, what you need to do? Again, number one, remove load. Okay?
Mm-hmm.
That means you take that out. Okay, number two. From the open circuitry, you're looking into here. You get the V, that V Thevenin. So when you remove that one, diode here will be open, right? The thing is you remove no current flow. You see that? You can get a diode, okay? If you get a circuitry, they will be look like. And this diode here will be open, okay? So that's why when you're looking into the circuit, okay, what V Thevenin equal? That will be telling you V Thevenin equal voltage here, VR2. Equal. Now you can using voltage divider. The thing is no current flow into diode path. So you can take 36, okay, time 3K divide 6 plus 3. So you can get that will be that will be 12 volt. Okay? And now you want R Thevenin. Okay, how do we calculate R Thevenin? They said you remove on of the source. That means voltage source shorted, current source open. So the circuitry now will be look like you short the power supply and you get right here 6K and you going down here 3K. Okay, and that will be shorted. So you're looking into here, Thevenin. So you can see you get 3K, 6K in parallel. Current flow this one, current flow here. So they will be 6 times 3, 6 plus 3. Is it 2K? That's why they get right here. Okay? And now, after you get Thevenin, you put everything back. That's why you can get right here. Okay? That is how to convert it.
Hey, Mr. Pham, can you go back to that stuff so we can, the bottom?
Could you scroll down, please?
Yeah?
Yeah, right there.
Yeah. To write down your notes.
Okay?
Okay, go ahead.
Now, you have to do for me. For number one, convert to Thevenin, I already did. Find current IL. To tell me what you get. That means now you put that back. Okay? You want the current flow to the IL. So, the formula IL equal 12 volt minus 0.7. Right here, they will be 0.7 right here. Okay, so 12 volt minus 0.7 divide 2K plus 1K. So IL equal 3.7 milliamp. And the VL 1K, so they can be 3.77 volt. Okay, number two, for this circuitry here, they want to know what V across IL. That means they want voltage here. Tell me, who get it?
9.3.
9.3?
9.3. Correct. You take 10 minus
0.7.
0.7. Perfect.
Silicon.
By current IL.
10 milliampere.
Come on.
9.3 divided by 1K.
Oh,
9.3 milliamp. What night? Find diode power. This is new for your guy. I given you the formula to calculate the power for diode. You take the V of the diode times I current. V diode means 0.7. Hey man, of what time out? What power you get?
$65.1.
6.51 milliwatt.
Hey, Mr. Pham, so do you take the 0.7 and multiply it times the current?
You take 0.7 times the current.
Yeah, that's what I said. Okay, yeah. Hey, Mr. Pham, don't move. You have to stay still.
Did you see the answer on the screen?
Yeah, we got you. I got it. I'm cool.
Okay.
Being recorded, so you can always reference it later too.
They can get it on Falstad.
Already done.
Number 3. Quickly, we ran out of time. For the circuit show, take 1V out. They're using 0.7 volt diode. Big thing you have to tell me right away, quickly.
Which one?
Number 3, what V out? Now tell me diode on or off.
I see number 2. Where's number 3 at?
At the bottom, it's on.
Scroll your screen, please, Mr. Pham.
Scroll
It's
your
nice.
screen.
No,
Scroll
no.
your,
Right now they on the top.
What?
Okay,
So
let's
diode is on. It's 9.3 in this case.
come on. Okay, now let's see. I want to make sure.
9.7.
I want to make sure.
9.3.
Let's see.
Mr. Pham, I think you need to roll your page down to the next page.
Okay, let's see. I stop and this one. Okay, I want to make sure I have to share. Okay, share again. Oh, that's it. It will stop screen sharing to the one. Okay, now I share here. So now you see that number 1.
We see number 3.
You see number 3, right?
Yes.
Yeah, 9.3 volts. Yeah,
That's correct.
that's what I said.
It's on. The diode is on.
Okay, we're done on that one. Okay, now number 3. What V out? Diode on or off?
On.
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 Okay, you say on. On means to substitute diode by 0.7 right here. Tell me what V out?
I see.
What V out here?
0.7.
0.7, yeah, 0.7 volt, 0.7.
7 volt, correct? We already said when you measure voltage across the battery, you get that battery voltage. Okay. Now, current IL. That one just a review. That means
100,
you guys
100 milliampere.
what? How many amp?
9.3.
9.3.
Yep.
10.
Okay, basically they supposed to be 10 volt
10 volt.
0.7.
And that's here.
So that's a wrong.
That's 100.
they supposed to be 9.3.
Yep.
Okay, I did wrong. Correct that. 9.3. The voltage across resistor here.
3.
What voltage?
9.3 volt.
Perfect. Number
9.
4.
0.
0 volt, yes.
Vout. Diode will be off, right?
Mhm.
Okay. What Vout?
0.
0.
Come on.
5 volt.
Off the open.
5 volt.
Oh, yeah, right. 5 volt.
5.
Not bad.
Current is 0.
IR is 0, yeah.
Current 0. Okay, number 5. Voltage across the diode, the voltage across here. So now, if you want it, then you have to using superposition. You sort that guy. You keep that one. Then you sort 10 volt. You keep minus 20 volt. Then you can find the voltage here. I given you the answer. Will be explained to you sometime. Voltage across diode 0.7 volt.
Minus 0.7 volt.
Minus?
Minor. Minor, the thing is why minor? That's a very easy. You don't have
It's a reverse bias.
You don't have to do any calculation. You can tell. Okay. If you
It's a reverse bias.
What?
Reverse bias, he says. Yep.
Okay, now I try explain a little more. Now, if you sort that guy, telling me diode on or off?
Off.
On.
Off, right?
Up.
The 40, 10 volts down here, diode off.
Up. Yeah.
When you sort that guy, you get negative, diode will be on.
On.
So basically, you combine, you get suppose you get negative here, and negative means diode will be on, and you get positive this side, negative the other side for 0.7. So that's why you get minus 0.7.
Yep.
Okay, this one I just given you the idea. Okay, thinking about that. We will get a meeting tomorrow, try to finish on the other side, on the lecture, and also on this part here. They say, consider the meter indication in each circuit. You need to tell whether the diode is working or whether they be open or short. So this is a troubleshooting. When you're working in the circuitry, you measure voltage at this point here, you get 25 volts. That means something not right. And you have to find out what is the problem. You have to tell the diode, is it they open or is it they shorted? Okay? Can you tell me only this problem? Then we'll be quick, continuing tomorrow. Only number 6, I want to see who telling me what you think. I measure right here, I get 25 volts. Telling me any problem with the diode, they open or they shorted.
Open. Sure.
you get 50-50, right? When they sort in it. But the thing is, when you say sorted, you have to prove for me. How come you get 25 volts?
Okay.
If you get, you say they open, then you have to prove it. Tell me how you get 25 volts.
And Mr. Pham, since the anode, I mean, the cathode is at ground and the other part, so it's a forward bias?
No. I'm telling you. Basically, the diode, when they measure for correct, they will be 0.7. Right?
Okay.
Diode will be on, so you can be supposed to get 0.7.
Right.
However, when you take the measure, do not get 0.7. You get 25 volts. So the question they asking you, tell me, the diode, is it they on or they off?
I think it's shorted because it shouldn't be getting 25 volts at that point.
Yeah, I agree. They measure, they get 25 volts. And the question they ask you, telling me the diode, is it they working or they on or they off, they shorted.
It's shorted. It's shorted.
It's open because if it is open, if it's shorted, then the positive lead where it touched the circuit, that should be 0 there. And since it's not reading 0, then it must be open. It's going through the circuit.
Yeah, you explain that is another way. You can tell me diode cannot be short, right?
Yes.
They short, you have to get 0.
Correct.
However, now they say they get 25 volts. Then now you say diode open, correct?
Correct.
Now
Okay.
asking you, how come you get 25 volts? Who can tell me?
The meter's broken.
Not technician yet.
Has the breakdown voltage?
No. Oh, okay. Now, when they open here, no current to 10K.
You're measuring across the diode, right?
Then they measure across 10K.
Right.
Right here.
Mm-hmm.
And voltage divider.
Voltage divider.
50 times 10 divide 10. That's why they get 25.
25, yeah.
Okay?
Mm-hmm.
So if you interview with me, I will be asking you. I measure at this point, I get 25 volts. Tell me, diode open or short? Then you say open.
Open.
That's correct. However, I will be asking you, how come you get 25 volts? Then you have to prove. You said no current go to this 10K. Okay? So the voltage measure will be across this 10K right here. Voltage divider. So that's why I get 25. Okay? Tomorrow will be continue that one and that one. Okay? I'm not trying to go anymore. Okay? Any question? I don't understand my program up to this point, I get 140 students. However, the show up on the Zoom here around over 80. I don't know where they go. They want to quit it or they want to drop it. We'll find
All right, Mr. Pham.
out. For sure.
Bye-bye.
Okay.
Thank you.
We'll see
Thank you.
you guys tomorrow.
Thank you. Have a good night.
Yeah, good night.
Hey, good night. Yeah.
Thank
Thanks
you,
again.
The fam.
Thanks, Mr. Pham. I like the last handout.
Thank you. Thank you, Mr. Fan.
Okay, we'll try to do the best.